Hello everyone. Today we're gonna implement the Trie data structure or the prefix tree data structure. Uh, this one pronounce is I think it's originally we can pronounce it tree, but it's cause a lot of confusion because we have the tree, the normal tree, and the prefix tree. So usually people will pronounce it as try to, to avoid the confusion. So this one is widely used in auto completing application and spell checker application. For example, if you search for a word in a documents, they usually use this data structure to have with those jobs. So how can we do that? For example, if we want to insert a word to our try data structure, it's gonna look like this. And uh, if we look at the full data structure uh, figures for the try, we can see that for each of the letter is gonna have a node to represent it, and, at the end, at each words, we're gonna have the leaf nodes, and we're gonna map all of the leaf node to uh, using a flag. So to insert a word, we're gonna start from the root node, and we're gonna check whether or not a new letter already have a path. If they don't have a path, we're gonna create a new path to this new letter. And when we reach to the end of the letter, we're gonna mark the flag is to uh, and for example, if we have and right here, we're gonna create a and d. If we insert and, we're gonna create d at the end because a and n already have the path. So uh, that's the insert operation. How about if we want to search for a word in a joint data structure? We're gonna start from the root node, and we gonna travel from the root through each of the letters the word. For example, if we have this try, we want to search for the word that, we're gonna go for D right here. For D right here, we go to this node, and for A right here, we're gonna go to this node, and we're gonna go to this node. And if we reach to the end of the node, we're gonna check whether or not the flag right here is true or not. So we're gonna call it is word, and make sure that we can check whether or not a word appear in our try data structure. And the third operation is we want to check if a prefix is if a prefix exists in our try. So we're gonna do the same for the searching a word operation. We're gonna start from the root node and move through each of the letter, the prefix. For example, if we had DA, we're gonna move this one and to this one. And whenever we have a letter which doesn't have a path to this letter, we're gonna know that this prefix doesn't exist in our trial data structure. So yeah, we're gonna have to check whether or not we can reach to the end of the prefix. So that's all for our Trie operation. And how can we do that? First of all, we're gonna have gonna create a new class for a try node. it will support our main operation right here. So we're gonna have a flag and word, right? Okay, I lint this end word right here and a next node is 26 uh, 26 pointers because we just have only lowercase English letters. So to make it easier, I'm gonna just fix. We have letter right here, and if we have more than 26, we're gonna use a. I think we can use hash map right here. Get all of the letter. Okay, and for the constructor, we just need to create a yeah. After that's all for the constructor. And now we're gonna need to implement the insert operation. So for the insert operation, we're gonna have gonna use a current node. And then we're gonna move each of the letter this word. So for character is this word, and we're gonna check whether or not we already have the path from current node to this character. So I'm gonna check if we have current. To make it easier, I'm gonna implement a function called get next node to the character C, and this function gonna return a pointer to the next node. Get next node. Gonna yep, make things easier. And this if this one return a null pointer, which means that we doesn't have a path or to the next character, and if not, we already have the path to the next character. So yeah, we just oh I'm sorry. I think if we have the different with null pointer, which means that we already have the path. So basically, we just need to move next one. And if we doesn't have a path, we need to create node. So to make things easier, I'm gonna create a function for create next node as well. And it is the with get next node. Yep. So that's all for this function. Oh, we're gonna have to mark in word right here as well. So that next time when we search for a word, our try data structure, we gonna know that if this word have an ending in our try data structure or not. So I think that's all for this function. And for the search operation, you're gonna do the same node, node, and then we're gonna look through all of the character word, and if we already have uh node, so which means that and go to the next character, next letter. And if not, if we doesn't have a path, which means that we cannot find this word, I'll try that. So basically we're gonna pause right here. And finally, we're gonna check whether or not if we can go to the end of the word, we can just check whether or not the current node in our try is ending of word. So basically, we can just return the current word. Yep, that's all for this function. And this one is pretty similar with the search for word thing. But we just need to return here because we don't need to check this is word or not. We just need to make sure that we have a path from the beginning to the end of X. I think that's all for main operation. And now we're gonna implement for each of the node. We're gonna have the get next node function. First of all, I'm gonna get the digit. Um, so this one, I just want to convert A C to 0 to 25 so that we can use a array to implement this one instead of using all the more complicated data structure. So I'm gonna have C character minus with A, then we just return next digit, and we're gonna first of all, we're gonna create a new node first. A nodes are then we have the next bit. And because we have the create, basically is and return accepted. Okay, I think that's all for the implementation. And for the time complexity, it's gonna be uh, O to the number of our character. And for the space complexity, is gonna be the number of nodes in our try data structure and the topic for this one. Try, of course, and pointer. Yeah, that's all for guess. Let's see how it goes. Good, right? You got accepted. So that's all for this question. It's help you guys.